Hello guys, in this video I'm going to show you how to solve permutations of a string. So given a string and a pattern, find out if the string contains any permutations of the pattern. Permutations is defined as the rearranging of the characters of a string. For example, ABC has following 6 permutations, and you can see the characters remain the same but in different order, right? A string has n distinct characters will have n factorial times n factorial permutations. Alright, so let's take a look at an example. So we're given the strings of id bcaf and the pattern abc, whether or not this string contains a permutations of abc. And the answer is yes. We have bci here, which is among the list permutations of this pattern. So can we retranslate this problem statement into something more familiar with us? So here essentially we need to define a substrings, a sub array of characters of this array of characters, right, that satisfies a given constraint, which is this subarray of characters must contain all characters in the pattern and with the correct frequency. For example, here we don't care about the order, but we care about the frequency of each character. So A appears once, B appears once, and C appears once, and we found a subarray that satisfies this is BCI, in which B appears once, C appears once, A appears once, right? So for this kind of problem, we're gonna use sliding window technique, right? We're gonna check subarray, different subarray, and at each each subarray will be a window. Right? We're gonna check the current window if it matches the pattern or not, right? And if it is not, gonna either expand the current window or shrink it down. Right. Alright, so let's get into it. First, let's run it into. Let's try to do it manually here to see how to solve it first. Alright, we have. Let's split it out. Oh, here is our pattern ABC, and here we don't really care about the cat itself, but we also don't care about the order, right? But we care about the appearance of the character and its frequency. So actually, to have access to these properties, we probably need a map with the structures where key is a character, right? and value is the frequency of that character. So here we have A frequency 1, B frequency 1, and C frequency 1, right? So with this in mind, we're gonna start. I'm gonna start. Sliding the window, right? So the window is actually 2 pointers, the start and let's say left and right. Here's left and here and right. Initially, it all points to the first character, right? So how we can keep track of the characters and frequency of the current window, and how to sync it with this pattern, how to check if they are equal. Yeah, you can. You can, of course, using two separate. Hmm, we can do the same with the window, current window, line with it with uh, the pattern here, right? I mean, we can keep track of a map of characters and frequency uh, of that character for the current window, right? So we must somehow maintain uh, two character map here and frequently check if they are equal, right? This can be a solutions, but sound a bit more complex and very hard to check the equality, right? A more simple way is that when manipulate this character map, right? And we can think that here is a here's a character map uh, we need to find, right? And mm, here is actually, let's think the frequency as the number of characters left to be found. So for example here, we need to find one character A in the window, one character B in the window, one character C in the window, right? So every time we add a new character to the current window, let's say uh, let's say when we add B here to the window, then it means our window already uh, had B, right? So we can subtract 1B from this character map down to 0. It means uh, we are done with B and we don't need uh, another B in our window. Right? So when all of the characters here, the count reaches 0, it means we have found a match window, right? All right, and a very important uh, observations here is that uh, our window right? Not only must match all of these characters, but also it needs to has an equal sign. For example, we have a window like A, B, D, C, right? As you can see, if we run to this window, then it seems like, even it seems like uh, our character map end up with A down to 0, B down to 0, C down to 0, because we have ABC inside here, but it is still not a match, right? So the other conditions that we need to check here is that the window size must equal to the pattern size here, right? But if the pattern size is 3, then the window must be 3, right? So with that in mind, let's get into coding. So we need first to build the CAM map first. And so it frequency map. Uh, it's just a literal objects, right? Object literal, and wanna look for every character in the string of the string. If it is not in the map, then we'll initialize with 0, right? And right after that, I will increment the frequency of character by 1. Alright, so down here, we're done with initializing frequency map. So that's when we can start sliding the window. Right? Window is just 2 pointer, window start, window end, and initialize with 0. Right? That. Window end equal to 0, window end less than the last index, which is string.length -1, right? But here is the right bound of last index. Window end plus plus plus. All right. All right. Um, at the beginning of each iterations, I will consider to expand our current window, right? Assuming that the current window is still a valid, right? It's still valid window. Assuming current window is valid, we want, by valid here I means, like for example, uh, the pattern ABC, a valid window can be A or AB, right? Uh, I mean it's still valid until now, right? A and B, it still matches A and B in the pattern. But if we have ADB, it's not a valid window. So zooming with convert a valid, we want to expand it. But yet to be matched. We want to expand the current window. So we expand it just by adding the character at the window end index. Let's say the right character is string at window end. I'm gonna add this one to the, so by adding this one to the window, it means that I will update the number to be found. I mean, possibly update the frequency map here, right? Because we're only gonna update it when the right character here, the new character here is character exists in the frequency map, right? If it does not exist in frequency map, we're gonna skip it, right? So if the right character is in frequency map, then I can update the frequency of right character by decrementing by 1, decrementing its frequency by 1. Right. Actually, the frequency map is uh, how many characters left to be found, right? So here, after updating by decrementing by 1, it could be that the frequency of that characters reaches 0, right? So in this case, I want to do something here, right? So how do I know that the when to stop? How do I know that when I have succeeded finding the matching window? I need another variable here. Let's say match. Here is a number of match, right? For example, when A reaches 0, we have one match. B reaches 0, we have another match. C reaches 0, we have the last match. So at that point, match variable here will equal to 3, which is equal to the size of the pattern. That's when we stop. Okay. Okay, when the new characters, right, the rightmost character, it is in the frequency map, and we update it, the frequency which is 0, we have one match. So I would increment the match count by 1. So because the match is changed, so after, so down here I can recheck, right, whether this match equal to the size of the pattern. down here when we exit and still not running into these conditions, I mean, will return false. Here, so here just the logics of expanding the window, right? So if we remain like this, if we just keep it expanding the window end from index 0 to the last index, right? And I mean it will run like this. It go here, it's 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 go here. And this is not what we want. We only want the window size to be at max the um, the number of keys in the character maps. Actually, it could be the pattern match or the pattern size here. Right? All right. Actually, the number of match here should be the the number of keys and the frequency instead, right? Because this could be different than the pattern here. For example, we have AABC, then we need only 3 match ABC, right? All right. So down here, when as I say, we only want to have our window to be at max of size uh, 4. Sorry, in this case ABC 3. So we can only find a window that matches the pattern if the window size equal to pattern size. Right? There's no way to check a window like this. Right? So when it reaches the size of the pattern, right, down here, and still not run into this here, still not a match one, we consider to shrink it down. So for example, OID, it is the same size pattern here, but obviously it's not a match. So I will consider to shrink it down one by one, right? So when I shrink down one character at a time. So after here, it reaches size 2, right? We can come back here to expand the window, right? Furthermore. Right? So again, we check this window is it match? No. If it's not, and it reaches the size of the pattern, we consider shrinking it down. Again, expand it. It's still not a match. Shrink it down. Expand it. Now we got a match. BCA, right? right. Uh, A is the size of window. Is the size of the window equal to what? Is the size of the window equals to the pattern size, and still not match the pattern, right? You can consider shrink it down. If the window size here actually, let's say window size is equal to greater than or equal uh, to the pattern size, and we still not run into here, it means I will shrink it down. Window size need to calculate. Window size actually window end minus window start plus 1, right? So how I'm gonna shrink it down? Shrink down window actually means we increment the window start by 1. Window start plus plus, but it is not enough. We need to update the frequency map here, right? So when we found a match here, we decrement its frequency by 1. In contrary, when I remove the character window start, and action window start, I need to increment the frequency here by 1. Frequency of lab character. Do we need to update the match here? And what is the case that wanna update it? So probably it when the current frequency is 0, right? So before update it here, I wanna check if the frequency of lab character is equal to 0, right? So down here it will increment by 1 to 1, right? So it means that in this case I want to, so 0 is a state of uh, match, right? Of one character match the frequency in pattern, right? But when it is from 0 to 1, then it means it is not a match anymore. I will need to update the match here. Okay, I think that is it. Let's run the test. Yes. Oops. We have a failing test here. Two failing tests. Why is that? Double check it here. Windows start at 0, window end at 0. So the character right here is EZ, character at window end, which is correct. So if this new character is in frequency, it means we can decrement the frequency or the number of this character by one. It means we have one less character to be found. If frequency it reaches 0, we increase the match, and when the match here is equal to the number of keys in frequency, it means we came out the characters, the number of characters to be matched. It is match is equal to this side. Return true, okay. And if it did not run into here, and if the current window size is greater than or equal to the pattern size, we need to consider shutting down the window. Oh. Not if it if this we only update the frequency of this lab character if it is in the frequency, right? If lab car in frequency. Oops. Not sure. Let's debug it. Let's debug it. Oh no, no, no. The wrong thing is that here we need to the frequency map must be from the pattern instead. Alright, works. Silly mistakes. So that is it for this problem. Thanks for watching. See you in the next video.